Directly I'll write the values of limiting friction. Problem is very simple if you analyze in one way. Limiting friction are 60 Newton. F2L is how much? This will be 15 Newton. Okay, now look at this. So he's asking find the value of F when F1 equal to F2. So definitely what assumption we can make it? Like if F2L is 50 Newton, then what is F1L? F1 will be how much? Will be 30 Newton. So definitely we are going for a condition where this is about to slide, M2 is about to slide, whereas M1 will not slip on the wedge. That's all, no? Straight away you can go for it rather than working so many things. So therefore, what is the friction between M1 and the wedge? Should be static. And here M2 open, I'll go for the limiting. So now you can ask question like, sir, on what basis you are writing F2 equal to like a limiting it is? I think that is what we have to verify, no? When F1 equal to F2 is asking at that particular situation, so is it F2 limiting or not? That has to be cross-checked once. So let's do assumption, let there no slipping at all surfaces. Then how the frictional force will be acting? The friction on the wedge will be like this. On the block, tension. This will be tension. This will be the tension. Then the friction here, the friction here, let it be F2. Now, shall we directly take a situation here? This should be the F2L only, because if it moves means it should be limiting only. Whereas here possibility of static friction. Will I agree? I'm just making problem very simple. Because if the block M2 moves means it should be limiting friction. Whereas block M1 what happen? Static friction can act there. So let's write equation. What is the net external force acting on system? F1, TT, this TT. So therefore, what is the acceleration of system will be A equal to F, or you are getting confusion, I'll write individual. F plus T minus F1 equal to MA. This is on the wedge. You look at the forces here. Applied force F, frictional force F1, and the tension. What force acting on the pulley should also act on the wedge. And here also is there. So what force acting on this pulley should also act on the wedge. So now, shall I have to add one more T for this? Okay, fine. So two pulleys are there, no? So what force acting on the pulley are also acting on the wedge. Vertical forces near to bottom because we are discussing motion along x-axis here. This is on the wedge. You write it here. And then for the block F1 minus T equal to M1A. Then T minus F2L equal to M2A. Just wait, I'll finish off this. Any key correction, you wait it. Huh? Let me finish off some good problems are there. So there should be, okay, this is F minus F1 equal to MA. I'll add up these two, F minus F1 minus F2L equal to M plus M1 plus M2 into A. Okay, this is the condition what we have, no? And it's telling F1 equal to 2F2, so definitely that should be F2L. So substitute here that one. So we know F1, F2, but we don't know acceleration. We don't know acceleration. So that I'll take help of the tension. So here I'll directly bring the condition. Let F2 is equal to.
Sir. Sir, then F1 will also be cancelled, right, sir? F1, if you add all the three.
T F1. Okay, this F1 is getting cancelled, no? Yeah. Okay. Thank you. I'll make correction. This will be and definitely this is F12. So now directly let's come for this one. F12 is how much? 15 equal to M is how much? 50. M1 20. This is 5. This is it. F is equal to 15 plus 75. Keep this equation. Let's come for this. T minus F12 is how much? We know 15. M2 is how much? 5. T is equal to 15 plus 5a. This value of T, I'll substitute here. This value of T, I'll substitute here. So I'll do one thing. I'll give the number 1, 2, 3, 4. Substitute 5 and 3. 5 and 3. So this should be 15 plus 5a minus F2L equal to M2A. Value of F2L 15. M2 is how much? M2 is 5a. See some the same equation I'm putting again and again, no? The equation 5 and 3 are same. So no need of writing separately here. Already that we wrote it. So what is the biggest problem here? I'll separately I wrote it. Okay, let it be this one. Okay, now what to do this? So F and A are unknown. Two unknowns are there. How to bring one more situation? So one more situation is needed here. So any help from? Shall I take somewhere here? I'll take equation 1. What is F1? F1 equal to 2FL. F1 equal to F2, no? Or 2F2L will become. So from 1 I'll write it rather than 3. From 1 we'll write it. F minus F1L equal to MA. Sorry, F1. This will be 2FL. This will be FL is how much? 30. M is how much? 50. This I'll call equation 5. Like this, you can check anything. Huh? I'm just took this one. F minus F1 equal to MA. So he is asking when this condition, when F1 equal to F2 is asking. So therefore F1 equal to F2. I'll assume that limiting friction will act definitely. So here, so F12 is 15. So I'll get this one. So solving 4, 5 and equating 4 and 5. Let's see that any equation will get it. It's a trial and error. Just you have to search the different. This 15 is equal to 25A. So A equal to how much? 3 by 5. That value of A substitute here. F should be equal to 15 plus 75, 3 by 5. This will be how much? 15 into 3. Anybody value? 60 Newton?
Yes, sir.
Okay, very simple way.